Hello everyone, we're going to be looking at how to do some more stoichiometry problems today. And I want to try to do some on the tablet and see how that works out. So wish me luck, we'll see what we can come up with. So today we'll start out with orange, right? And the first problem that we're going to do is, I don't know, let's just do a simple one. Let's go with this. We're going to go with sodium plus chlorine gas is going to yield sodium chloride, okay? So this is the raw equation, and what I'm going to do now is go ahead and balance that. And in order to balance that, I'm going to have to put a 2 here, and I'm going to have to put a 2 here. And I'm just doing that pretty quickly because I want to make sure that I don't spend time on stuff that you guys probably pretty much have mastered already. So anyway, we have just balanced this equation. And now here's my question I'm going to ask. It's going to be how many grams of chlorine gas is needed to make, I don't know, we'll just come up with something. How about 252 grams of NaCl? Okay, so that would be the question that we would ask, and we're going to be using basic stoichiometry to get this done. And let's see, the first thing I want to do is I'm going to underline chlorine. Actually, let's do it with a different color. Whoops. And let's see, come back over here. And we'll change this to a different color. Let's make it green, right? Because why not? So we're going to put a question mark underneath chlorine. And this is going to be question mark grams. And I always mark my balanced equation like this because it helps me understand what I'm doing. It really gives me like a visual cue as to what's going on. Then I'm going to underline NaCl. And I have some information about NaCl, don't I? I have 252 grams of NaCl. So we have that. So now the next thing I'm going to do is I'm going to set up my problem. And we start with what we're given, okay? So we're always going to start with some kind of a number that we're given. So I'm going to write 252 grams of NaCl. I'm going to write that right there. And I'm going to go ahead and draw my big long lines. And I know it's going to be a pretty long one because I'm going to have to, first of all, go through molar mass, right? Then after I get molar mass, I'm going to have to do mole ratio. And then after mole ratio, I'm going to have to go back and do molar mass again. Only this time I'm going to do molar mass to convert from moles of chlorine into grams of chlorine. Okay, so let's go ahead and try to figure stuff out. The first thing I need is the molar mass of NaCl. Well, Na has a mass of 23 grams per mole, and Cl has a mass of 35 grams per mole. So that's going to be 58 grams in every 1 mole. Okay, so that's my molar mass for NaCl. So I'm going to write that on here. And which one do I put on bottom and which one do I put on top? Well, it depends on what's going on over here. I know that grams are on the top over here, so I'm going to have to put 58 grams of NaCl on the bottom over here so that grams can cancel. And then I put 1 mole of NaCl up top. Grams are canceled, and I'm left with moles of NaCl. The next thing I want to do is my mole ratio. Now the mole ratio is based on the balanced equation. So that's based on the coefficients. There's a 2, here's a 1, right? That's a 1 here. And then here's a 2 here. So this is a 2 to 1 to 2 ratio. In other words, it's going to take 2 moles of sodium to make 2 moles of NaCl. It's going to take 1 mole of chlorine to make 2 moles of NaCl. And so we're going to use that. We're going to use the 1 mole of chlorine and the 2 moles of NaCl to do this. So I'm going to put 2 moles of NaCl on the bottom. Why did I do that? Because I want moles of NaCl to cancel. And I'm going to put 1 mole of chlorine gas on the top because that's what we're converting into next. Okay, the next thing I'm going to do is I have to do the molar mass. And this time it's the molar mass of chlorine gas. Well, let's see, chlorine gas is going to be 2 times 35, which is going to equal 70 grams per mole. And that's the molar mass of chlorine gas. So where do I put mole and where do I put gram? Over here I put gram on the bottom, right? But here I'm going to have to put gram on the top. And I want to do that because remember, well, I think there's a dead spot on my iPad right there. So this is 70 grams of chlorine gas on top and 1 mole of chlorine gas on the bottom. And check it out, moles are going to cancel, and that's how I know that I want to put moles on the bottom. Now that I have all of this done, all I have to do next is the math. Well, on a calculator, it would be 252 times 70 divide by 58 divide by 2 and then equal. And I haven't done the math yet, so let's do it right now. Put that into my calculator. I just kind of made up numbers as I went. So 252 times 70 divide by 58 divide by 2, and I'm going to get 152. So it's going to be 152.0689555 blah blah blah. So let's look at sig figs. I have 1, 2, 3 sig figs in my original answer, which means I can go with 1, 2, 3 sig figs in my final answer. So my final answer is going to be 152 grams of Cl gas. And that is my answer. Okay? So let's go do another one. I think I should have a little bit more time left. And by the way, I'm going to have you guys take notes on these. We're still just watching me do them. Very soon we're going to be doing them ourselves. But I wanted to, start out with these by myself first so you can see how I'm doing it. And let's just use the same balanced equation. So we've got Na plus Cl2 yields NaCl. Now let's balance it. It's going to take 2 moles of this, 1 mole of chlorine, and 2 moles of this. We always have to have a balanced equation in order to do a stoichiometry problem. And if you ever start a stoichiometry problem and the equation is not balanced, then it's just not going to work. Okay, so you always have to have a balanced equation first. So this time, let's say how many moles of let's see, NaCl can be made from, this time let's go really crazy. And let's say from, I don't know, 2.77 times 10 to the 24th atoms of sodium. Oh man, now we're really getting crazy. This is going to have this. Whenever you see something like this, you know you're going to be working with Avogadro's number, right? And remember, Avogadro's number is this: 1 mole of anything is going to equal 6.02 times 10 to the 23rd anythings. And so in this case, we're dealing with atoms. So we know if we have 1 mole of atoms, it's going to be 6.02 times 10 to the 23rd atoms. So let's start with what we have, okay? And we'll just go from there and see where it takes us. 2.77 times 10 to the 24th atoms of Na. And I want to get, oh wait a minute, I forgot to do that up here, didn't I? So let's see, we're going to go with 2.77 times 10 to the 24th atoms. And where are we trying to get to? We're trying to get to moles. Moles, question mark. Okay? So we want to make sure we do that, and I almost forgot there for a second. So here we go. We know what we're going to go for. How are we going to get there? Well, the first thing we have to do is we have to convert out of atoms and into moles. Remember, everything has to go to moles before we do anything else. So to get from atoms into moles, you're going to have to use Avogadro's number. So I'll put on here Avogadro's number. We have to put that on here. So let's do it. And I'm going to put the number on the bottom. 6.02 times 10 to the 23rd atoms of sodium is going to be the same as 1 mole of sodium. Okay? Now, atoms of sodium just went bye-bye. They're gone. And we're into moles of sodium. But we don't want moles of sodium. We want moles of sodium chloride. Okay? So I'm going to have to use a mole ratio. And what is the mole ratio between sodium chloride and sodium? Well, it's going to be a 2 to 2 ratio, right? It's a 2 to 2 ratio. And that means I'm going to put in here, and you know, sometimes people will do the math in their head and just put, well, 2 to 2, that means a 1 to 1. I know. I just leave it where it is and don't even worry about trying to do any conversion of math in my head at all. So I'm just going to put down here 2 moles of Na. Excuse me, sneezing. And 2 moles of NaCl on the top. Moles of Na are going to cancel, and I'm left with moles of NaCl. Oh my goodness. Don't worry, I don't have COVID, I promise. Okay, so now I made it. I made it to exactly where I wanted because I wanted question mark moles, right? So now I just have to do the math. And when I'm doing the math on the calculator, it's going to look like this. 2.77, and then I'm going to use my EE key, and then I'm going to type in 24 times 2 divide by 6.02, that EE key again, 23, and then divide by 2, equal button. And that's how you put it in. So here we go. I'm going to have to use my good calculator for this. I can't use my stupid calculator I had sitting here. So here we go. I'm going to pull up my other calculator, turn it on its side, and put in 2.77 EE 24 times 2 divide by 6.02 EE 23 divide by 2 equals, I've got 4.60132 blah 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 blah. How many sig figs do I have to begin with? To figure out sig figs, you go back to the original answer, and it has 1, 2, 3 sig figs. So my answer can have 1, 2, 3 sig figs. So my final answer is going to be 4.60 moles of NaCl. And that would be my answer. Okay? So hopefully these are helping you out. And I don't know how much time I have left on this video, but I'm going to try to do one more and see if we can, I guess, try some more. And what I want you to do is take notes of these, and then you're going to take pictures of your notes as I'm doing them. You're doing them as well, okay? So you're just basically imitating me at this point. So let's see if we can get another one done. I'll try to do this one a little faster. We'll use the same equation. Na plus Cl2 yields NaCl. 2 of these, 2 of those. Okay, this time let's do question mark atoms. If we're given, let's use this one. Let's do 22.4 grams of this. Okay, so I need to figure out how many atoms is it going to take to react with 22.4 grams of chlorine. Oh, wait a minute, we're not using this guy at all? No, we're not. We're not going to use him at all. Instead, we're going to just stay on the reactant side, and yes, we can do that. So let's do this one in red. Here we go. So we're going to start with what we have. 22.4 grams of Cl2 gas. And I want to convert that into how many atoms I'm going to need of sodium to react with that. Well, let's see. We know the molar mass is first. So molar mass, I can't write. Molar mass is going to be first. Then we have to do a mole ratio. Then we have to do Avogadro's number, right? because I want to know question mark atoms. And whenever you see the word atoms or molecules, you know you're going to deal with Avogadro's number. All right, so molar mass of chlorine. We know from a previous one that it's 70. So 70 grams of Cl2 is the same as 1 mole of Cl2. What's the mole ratio? Well, that's going to be a 2 to 1, right? That's a 1 there. So it's a 2 to 1 ratio. So let's write that in there. 1 mole of Cl2 is going to go on the bottom so that it can cancel our grams. And then we're going to put 2 moles of Na on the top. Now, 1 mole of Na is going to equal 6.02 times 10 to the 23rd atoms of Na. Moles of Na are going to cancel, and I'm left with atoms of Na. We did it. There it is. How would you do this on the calculator? 22.4 times 2 times 6.02, and then that EE key, and then 23, divide by 70, equal button. So let's do that one real fast. My calculator turned off again. Turn it on its side, clear it. Here we go. 22.4 times 2 times 6.02 EE23 divide by 70 equals, and I get 3, oh, that's that dead spot, 3.8528 times 10 to the 23rd. But we don't want that. Go back over here. Sig figs is 1, 2, 3 sig figs. So 1, 2, 3 sig figs. So that's going to be 3.85 times 10 to the 23rd atoms of Na. And that is our answer. Okay, so I'm going to publish this for you to watch, and then I want you to submit your notes, basically copying what I just did.